These notes are for integrated 2. This is section 8.2.1. And this is going to be fairly dense, so make sure that you have the notes in front of you so that you can fill in as you go on this. Angles of polygons. So first we want to talk about the idea of what a polygon is. Well, a polygon is a completely enclosed shape. So an example of a polygon is a square. It's all created by straight line segments. That's important to note. So a common shape that is definitely not a polygon is a circle, since it's not created with straight line segments. Now, we typically name polygons based off of the number of sides that they have, which some of these names should look familiar to you, hopefully. But in general, we refer to a polygon. You don't even, you do need to know the specific names for the ones that are identified here, but once you get up to a polygon that's got like 15 sides or a polygon that's got 27 sides, which those do exist, we refer to them as a specific n-gon. So you can see this example here of the 11-gon. It's an 11-sided polygon. So instead of saying the 11 and then sided polygon, we get rid of the sided and the poly part in front of it. So if you wanted to talk about a 24-sided polygon, we would say it's a 24-gon. So in this general term of this whole n-gon business up at the bottom. All right, convex versus non-convex. All right, well, you're also going to see that another name for non-convex, so we're clear on this, is called concave. And I prefer the concave part because it helps me remember what these guys look like. So a polygon is called convex if each interior angle can be connected by a line segment without leaving the interior of the polygon. Okay, that sounds like a mouthful. Here's what I think of. If you take a look at the entire polygon, and we take a look at this convex polygon, so I'm going to use my blue pen here. If you were to trace each one of the corners, it looks like the corners are pointing out of the shape. Now, it could be slight, but they're definitely pointing outwards with all of these. That's a convex polygon, and it looks like if you extended them, it kind of looks like the tip of an arrow pointing outwards. A non-convex or a concave polygon, that doesn't work the entire time. Like you can see over here where I just highlighted in orange, it looks like an arrow pointing out. However, it doesn't work that way with all of them. You'll notice that there, it looks like an arrow tip pointing inside the shape. So I always think of, and this is just a way that I remember, is that when I think of a concave polygon, I think of a cave. And what do you do to inspect a cave? You go inside it. So if any of the corners point in, it's like you're walking into a cave. So it's concave. If all the arrows point, or all the corner arrows kind of point out, then it is convex. If it helps, great. If it doesn't, you don't have to use it. Okay, moving on. So a regular polygon. All right, to be regular means a couple of things when it comes to polygons. It means that it is convex. That's important. All of the sides are congruent and all of the angles are congruent. So you kind of take a look at this picture over here, and it's just loaded with a whole bunch of markers identifying that all sides are congruent, all angles are congruent. And you'll notice that we do have all of the two side lengths coming together to create a corner, and it looks like the tip of an arrow pointing out. Okay, then we've got some vocabulary here. So vocabulary for a polygon. Now, the radius hopefully makes sense. Typically, the radius comes from, think about a circle, comes from the center and goes to the circumference of it. But in this case, the circumference of this, or the radius specifically, would go to a corner. That's important to note. So a radius is from center 2, you can all call it a corner, or it is a vertex also. So from center to vertex. Then we have this other vocabulary word, which is called the apothem. The apothem goes from the center to a side length. It is also going to be perpendicular to that side length. So the apothem goes from center to side. It is also perpendicular to the side. So it almost looks like the height, kind of, because we know the height is perpendicular to the base. So you do have that 90-degree angle occurring here. Like I said, this is going to be kind of dense. So let's take a look at the next one. So we have sum of interior angles. All right, so what I have here, and I drew it off to the side for you guys, so it's not necessarily in the notes. You're probably going to want to add it for yourself, is I drew a regular. So all of the sides here are congruent. All of the interior angles are congruent, and it is 2, 4, 5 sides, so this is a pentagon. All right, so just so we know, what I have here is a regular pentagon. And I wanted to show you a couple of things. So if we want to talk about the sum of the interior angles, so the sum of the interior angles, I'm going to go ahead and highlight this in blue. So, and I'm going to kind of erase as I go because I'd like to use the same picture. So you might want to draw this a couple of times. The sum of the interior angles, it doesn't matter if it's regular or not. It just has to be a polygon. What you want to do, and you've experienced this with one of the lessons, start from any corner you want, doesn't matter. What we want to do is we want to create triangles. So starting from this corner, I am going to create triangles by going from this corner to every other corner in the shape. Now, if I go to this corner over here, that's not going to give me a triangle. That's just a straight line segment. So connecting to the corner that's right next to it isn't necessarily going to help me. So I'm going to work my way around this shape. So if I connect there, okay, I have a triangle. So this is going to be my first triangle, number 1. And I'm just going to keep going. Start back at the same corner and go to the next one. This is going to give me triangle number 2. You'll notice that by creating that, I also created triangle number 3. So in my 5-sided shape, I ended up with 3 triangles. So 5 sides gives me 3 triangles. Okay, well, we know the sum of the interior angles of a triangle. So each triangle is 180 degrees. So I basically have 3 180 degrees. So I would go ahead and multiply this out, and that's going to give me 540 degrees. Notice though, so I'm going to have all these triangles. So by chopping it up into triangles, that's where my 180 degrees comes from. The 3 is the key here though. That's important. If we go back to the triangle, I'm going to grab my purple pen for this one. So, back to the pentagon. You'll notice that I was able to create 3 triangles by connecting to the different corners. But I want to know why it's not 5 triangles. And it's because of the first line segment that I put in. If I start at the original corner and I use my purple, that was the first corner that I would have connected to. But by creating the purple line segment, I don't create a triangle there. So I don't get the 180 degrees. Notice it happens again at the very end. So my other purple line segment, by connecting to the adjacent corners, so corners right next to the one that I started at, I'm not creating triangles, I'm creating line segments. So that's not necessarily going to help me with this whole 180 degrees business. So if I were to have, hypothetically speaking, let's say I have a 12-sided polygon. So let's say I have a 12-gon. I am going to create all of those line segments to be able to create the triangles. But I'm not going to connect to the two corners that are right next to the one I start with. So those two are taken out. So now I'm at 12 and I've just diminished it by 2. So what I will have created is 10 triangles. Well, I know that each triangle is 180 degrees. I can multiply those, and that's going to tell me the sum of the interior angles. So that's where this whole -2 comes from, because you don't connect to the two adjacent corners. So here what we have now, let's highlight this in orange, is our formula. So the 180 degrees is per triangle, and then the n-2 represents, well, how many triangles, where n represents the number of sides that are actually in the sides in the polygon itself. Okay, I'm going to erase my marks now inside my pentagon. I'm going to take a look at the next one. I want to do the sum of the measures of the exterior angles. Okay, so this is going to take a little bit of visualization on your part. So what I'm going to do is I'm going to start at a corner. I think I'm going to start at the same corner I did just a minute ago. And I am going to use a red line segment. And basically what I want to do is I want to extend every side. So I'm going to start at the same corner that I was at. Put a little red dot there so you know where I am. And I'm going to choose a direction to extend a side. I don't want to extend both of them. So I don't want to do that and that. I don't want to extend both of them. I'm just going to choose one. So I'm going to choose that one. Then I'm going to move over to the next corner, and I'm going to extend it in the same fashion. But I want it to look almost like a pinwheel. So I know right around the 4th of July holiday, you normally see those little pinwheel fans in people's yards. I want to kind of make this look like a pinwheel. So I'm going to extend the sides. So I'm just trying to show you where this comes from. Keep extending the sides all the way around. And keep extending the sides all the way around. There we go. Okay, so now, kind of if I put a little spinner in the middle, so I've got my little center part here, and it was on a stick, and the wind was coming, you should be able to see that it's kind of blowing around in a circle. So it's blowing around in a circular pattern. So by blowing around in a circular pattern, what I know is that all of those extensions are going to give me this whole circular pattern. So when I think about the degree of a circle, well, the degree of a circle, if you just kind of turn yourself around, is 360. So if I were to add up all of those angles, it would give me a circle. So that's one way to take a look at it. All right, let's get rid of those marks. Remember what I said, I'm going to be using this picture a couple of times. Okay, then I want to do the measure of an interior angle plus its corresponding exterior angle. All right, let's go ahead and put one more of those back on. So I'm going to use the bottom right corner this time. So I'm going to go ahead and mark that in purple. So bottom right corner is where I'm looking, so my purple dot. And I'm going to take a look at the extension of that. So notice that I extended it so I have an interior angle and an exterior angle. So here is the interior angle. And then here is the exterior angle. And I think it's pretty easy to see, since we've done a lot of stuff with supplementary, they are supplementary to each other. So if you have an interior angle right next to its exterior angle, then we know that they make a straight line, which means these are supplementary angles. Hence, our 180 degrees. Okay, going back to our picture again. Remember, I warned you this was kind of dense. Okay, regular polygons. We're talking specifically about the regular polygon. Now, everything else that we just did, could refer to any polygon, okay? Let's talk about our regular polygon now. So I'm going to go ahead and grab this guy and I'm going to move him down. Make it just a tiny bit bigger, not a huge amount. And let's see if we can add some more information into this. So this is me being able to talk about the size of each thing. So each interior angle, each exterior angle. That's important to know. We are talking about each at this point. Okay, so if we're talking about each interior angle, all right, well, we know the sum of the interior angles. So if I'm talking about the interior, so I'm now using since we're still talking about interior, I used blue. So let's go ahead and use blue again. So if we know the sum of the interior is going to be equal to, well, go back up to our formula. It's 180 degrees for each circle, for each triangle. And then we're not going to connect to the two nearest corners because that doesn't give us a triangle. So if I know that that is the sum, so I've kind of got my picture going again here. So there are my three triangles. So the total of all of the angles, so really what I'm looking at here is this angle up at the top, this angle here in the corner. Now, if it is regular, I know all of those are the exact same size. So if I add them all up, that's the 180 times n minus 2. But if I want to figure out how big each one is, well, this is a 5-sided polygon, which means it has 5 interior angles. N represents the number of sides and angles that it has on the inside. So what I want to do to find each interior angle, going over to my formula, we're going to find the sum of the interior angles, and we're going to divide it by the number of interior angles. So I'm going to divide it evenly. So in this case, I would take my 180 times 3, which we already decided, and then I'm going to split that evenly to every single corner. That would be 5. So this is the measure of each interior angle in this case. Okay, now we did exterior angles, and exterior angles could either be red or purple. I think I'm going to grab purple. All right, now I'm going to go back to my picture and I'm going to get rid of my marks here. So I want to use this again to represent the exterior. Hopefully you're hanging in here. We had kind of a lot going on. All right, so now we are talking about the exterior angles, the measure of each exterior angle. Well, it's the same idea. So we know that the exterior angles are when you extend from each side, that whole pinwheel idea. Oh, so we've got the whole pinwheel idea here. I know that the sum of those is going to be 360 degrees. So I'm going to do the exact same thing. I'm going to do the sum of the exterior angles, which it's pinwheel. Pinwheel looks like a circle. Sum's going to be 360 degrees since that's the degree of a circle. Then I want to split it evenly. Now, because this is regular, I know that the size of each one of these exterior angles are going to be the exact same size. Now, if you have a 5-sided polygon, then there are 5 corners, which means there are 5 exterior angles. If you have a 27-sided polygon, you have 27 exterior angles. So we need to divide by however many exterior angles you have. So over to our formula here. It's the same idea. This is the sum of the exterior angles. And then we're going to divide it by the number of exterior angles. Okay, lots of formulas. Now we can actually get into some practice here. So suppose you want to draw a regular 72 polygon. I do not want to do that. 72 sides, and they all have to be the exact same length, and every single angle has to be the exact same size. So I'm not going to draw it, but suppose I want to. That means, so let's write down what we've got here. With this regular 72 gon, that means all sides congruent, all interior angles congruent, because it's regular, all exterior angles congruent, and think about how many triangles I could draw in this. So I could chop this up into 72 minus 2, so 70 triangles if I dissected it, so chopped it up into pieces. What is the sum of the interior angles? Okay, the sum of the interior, okay, that is all the triangles. Well, there's n minus 2, which we already determined in this case was going to be 70. So that's the number of triangles, and then the value or the degree of each triangle is 180. So then I'm going to take that 70 and that 180, I'm going to go ahead and multiply them together. So that's going to give me 12,600 degrees. Definitely not something that I would want to draw. Okay, number 2, suppose you would like to draw a regular 13 gon. Okay, it's regular again. So all sides are congruent, all interior angles are congruent, all exterior angles are congruent, and inside I can draw 11 triangles. So remember, you can't connect the two corners closest to you to actually make a triangle. What is the sum of the exterior angles? Okay, sum of the exterior. Okay, that's my pinwheel. And it's the sum, so I'm adding them all up so I get the entire circle. That's going to be 360 degrees. Honestly, it doesn't matter how many sides you have because you can create the pinwheel out of it. Okay, solve for x. All right. Well, we know this looks like a polygon to me. I have no idea if it's regular. Nobody told me. I'm not going to assume. So I think I can do the sum of the interior angles because those all look like interiors to me. So let's do sum of the interior angles. All right. Well, let's go over here and count how many corners I've got. So this is a 1, 2, 3, 4. This is a 5-sided polygon. 5-sided polygon. Okay. So that means that I can do 5 minus 2 triangles. So remember, connecting the corners. And each triangle is going to be 180 degrees. All right. So to find the sum, I think we're going to do 3 times 180. All right, let's multiply those together. So 3 times 180, that's going to give me 540 degrees. So basically, if I add all of the interior angles up together, I better get 540 degrees. Okay, well, let's do that. We're actually going to write an equation here. So I'm going to start at one of the corners. I think I'm going to start at the 3x minus 5. And I'm just going to go around. So plus, so that takes care of the 3x minus 5. Let's go up to the next one, x plus 48. Plus, go to the next one, 2x. Plus, go to the next one, 2x minus 15. Notice I'm just working my way around the inside of this polygon, 125. And then just make sure you went all the way around. So 3x minus 5 was one of the angles. X plus 48 was the second angle. 2x was the third. 2x minus 15 was the fourth. And 125 is the fifth. You should have 5 because this is a 5-sided polygon. Well, we know what the sum should be. It should be 540. So go ahead and set it equal. Now, it's just a regular algebraic equation. Why don't you see if you can solve for x? Okay, going through and solving my equation, I combined like terms. Looks like I have 8 x's total. Combined all of the constants, got 153, and then I went through and solved. The key to this, the first part really is figuring out, well, what is the sum supposed to be? So I got to come up with the 540 first in this case. Now, if it was a 7-sided polygon, then there would be 5 triangles at 180 degrees apiece. So the beginning part is super important. You want to make sure that you actually figure out what the total is supposed to be. Okay, moving on, getting closer to the end here, folks. We want to find the number of sides. Okay, number of sides. So the number of sides of a polygon. That means that we are looking for n. So find n. That's important. Whose interior angles, when added, all right, this sounds like the sum of the interior angles. Interior angles, when added, will be 6120. Okay, so what we're being told here is that the sum of the interior angles is equal to 6120. Okay, so I think we need the formula for the sum of the interior angles. So, sum of the interior angles, that is the number of triangles you can cut this thing up into. So, we know we'll have 2 fewer than the number of corners, and we know then that each one of those is going to be equal to 180 degrees. Okay, this represents the sum. But I'm being told what the sum is. So let's set this equal to the sum that was given to me, which is 6120. Now, we want to solve for n. There's a couple of ways to do this. You could distribute the 180 in the parentheses to get rid of it. That's one way to do it. Or this 180 is currently being multiplied to n, right? Multiplied to n minus 2. Well, let's just divide it then, so we can actually just get rid of it. So I'm going to divide this side by 180. Again, not the only way to do this. It's one way to do it. We know that 180 divided by 180 cancels. Notice that we don't need the parentheses anymore around this. And then we're going to want to divide this. Now, important to note here, in order for this to even have a shot at being an actual valid question, remember, n represents the number of sides that a polygon has. When you perform this division on the right-hand side, that 6120 divided by 180, it better be a whole number. If you get a decimal, that doesn't make any sense. You can't have part of a side, and it sure better not be negative, because that also doesn't make any sense. So we did divide, worked out evenly. Let's go ahead and add our 2 to the other side. So basically, what we have here is a 36gon. There we go. That is the polygon that is going to give us an interior sum of 6,120 degrees. Okay, a regular polygon has an interior angle measuring 160 degrees. All right, so this is a single angle inside a polygon. So it does have an interior angle measuring 160. So basically, we want to know, or we know that each interior angle is 160 degrees. Each interior angle, not the sum. Well, it couldn't be the sum anyway. It's got to at least be 180 degrees to be the sum. Each interior angle. How many sides? All right, it looks like we are trying to figure out n. So how many sides does it have? So solve for n. All right, let's look at the information that we've got here. We've got each interior angle. Okay, well, if you take a look back at the notes, each interior angle in a regular polygon, well, we're going to take the sum of the interior angles and we divide that by the number of interior angles, so however many we have. All right, so let's say Sum of the interior angles. All right, we know there's going to be 2 fewer than the number of corners, and we know that each one of those is going to total up to 180 degrees. Those are all my triangles inside. But then I need to split that total to every single corner. Well, there's n corners in each polygon, regular polygon. So this represents each interior angle. So this is each interior angle. But I know how big the interior angle is. So I think I'm going to set this n minus 2 times 180. So the sum split evenly to every corner. I'm going to set that equal to what was given to me. Well, I was told it's 160. Now we need to solve. So kind of going back to some stuff that we had done previously when we did trigonometry and we had fractions. I said, okay, we'll make everybody look like a fraction. Let's do the same thing. So I'm going to put a 1 under here. Hopefully this indicates something that I should be doing. So I'm going to cross multiply. So that's going to give me n minus 2 times 180 times 1. That doesn't really do me any good. And then 160 times n. Now, what I did previously where I divided by the 180, that's not really going to help me here because I have an n on both sides of the equation. I think I'm going to have to distribute. So let's do that. So I'm going to distribute my 180 inside. So it's going to give me 180n minus 360, and then just drop the rest of it. So 160n. Okay, now we're at the point where we just go ahead and solve. So let's go ahead and subtract that 180n to the other side. I'm a little concerned at first because I see negative signs, and I know that doesn't make any sense, but that's okay because I've got a negative over here, 360. I think they're going to cancel. That's a negative 20n. Divide by negative 20, and this is n, this represents the number of sides or the number of interior angles. This better be a whole number. So if I do 360 or negative 360 divided by negative 20, I get n is equal to 18. So it looks like what we have here is an 18 gon, which doesn't have a fancy name, so we're just going to go ahead and call it that. Okay, coming in on the home stretch. Here we go. A regular polygon has an n exterior angle. So this is a single exterior angle of 15 degrees. What is the measure of the interior angle? Like, we'll get to the and part in just a second. So we want to know the measure of the interior angle. All right, so here's what we know. We know that interior angles and exterior angles create a straight line when you put them together. So if I take the interior angle and I add it to the exterior angle, I better get 180 degrees because they are supplementary with each other. Well, I don't know the interior angle, so I'm just going to leave it as interior angle. You could call it X or Y or N, or I wouldn't call it N. N represents the number of sides. And the exterior angle, well, we know what that is. We were told that exterior angle is 15 degrees. And then this one's not so bad. Let's go ahead and subtract the 15. And then I think that'll give us the size of, and this is a regular polygon, so that means each interior angle. So our interior angle is going to be equal to 165 degrees. Okay, and I'm going to go ahead and box this one just because I got a couple of things going on here. So now let's take a look at the next part of the question. How many sides does the polygon have? Okay, that's n. Now remember, n has to be a whole number, so solve for n. Okay, well there's a couple ways to do this. We can deal with the interior angle or we can deal with the exterior angle. I think I'm going to deal with the exterior angle only because we haven't done that yet. So I know that I have each exterior angle. Okay, so each exterior angle is equal to 15 degrees. That was given to me. Okay. I know that the sum of the exterior angles, that's my pinwheel, is going to be 360 degrees. Okay. I know to find each exterior angle, I am going to take the sum of the exterior angles And since it is regular, I'm just going to chop it up into all of its equal parts. So I'm going to divide by the number of exterior angles. Okay, so let's see. The sum of the exterior angles, that's 360. The number of exterior angles, that's n. Each exterior angle, that's 15. All right, I'm going to put a 1 under this guy and let's cross multiply. So it's going to give me 360 is equal to 15n. Let's go ahead and divide by 15. Remember, n represents the number of sides. So this better be a whole number. If it isn't, we made a mistake. Oh, it is. Good. 24. So I would say that this is a 24 gon. So that's the other answer to my question. Oh, and we reached the end.